As discussed previously in low and high frequency response examples, each frequency response is drawn in separated bot plot. I mean, the low frequency has been drawn in a different pages of the bot plot, and another high frequency we draw for the second paper. Below is a gain versus frequency plot in dB for low and high frequency response in I say the overall response. So for the overall, so we can see the high and low frequency response here. So we see that, for example, this is a example from another amplifier. For example, here the FLE, this is asymptote for the FLE, and then FLC, then FLS. So now FLS is the cut-off frequency because it has a highest value compared with the FLE and FLC. And this is the FH in and FH out. So FH in is the cut-off frequency for the high. So we say this is FH and this is FL. So this is the frequency now. Okay, so we get the bandwidth now here is F2 minus F1. So you get the bandwidth, and now you can see the frequency, low frequency response is produced by coupling and bypass capacitor at low frequency, and for the high frequency produced by the interelectron and wiring capacitance at high frequency. So if you see here is negative dB per octave, means that this is equal with negative 20 dB per decade. Okay, so if you notice here, the curve has the same slope, is in negative 20 dB. However, at this point it will break again here, become negative 12 dB per octave. It means it become 40 dB per decade. Okay, and this because something happened here. The FH out make the FH in break somewhere around here. Okay, so for this one is in positive dB per decade. Okay. And this is another, if we draw in a full paper, this paper is special because it has more cycle. We have 1 cycle, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have about 10 cycles, for the graph. So it can fit both low and high frequency response. So we can draw our frequency response here. For this frequency means you get for the low and for the high, and this is the actual response for low and high. The bot plot not only indicates the cut-off frequencies of the various capacitors, it also indicates the amount of attenuation or loss in gain at this frequency. The amount of attenuation is sometimes referred to as roll-off. The roll-off is described as dB loss per octave or dB loss per decade. So this is what we call the roll off. Okay, when it breaks, it become actually the first line here. This is the first line. The first line is 20 dB per decade, and when the roll off happen, the loss here, this line is 40 dB per decade. Okay, that's all for the chapter 6, the BJT frequency response. Thank you for watching.